this video we're going to look at how to factorise expressions using the method known as the difference of two squares. Now this doesn't always work for quadratics, it's only if they take a special form, and that form is if we have one term subtract another term, and then we can use the difference of two squares. And it usually makes sense to do it when both of the two terms can easily have these square roots evaluated. So this first example, I can find the square root of x squared easily and the square root of 4 easily. So, and there's a difference, they're being subtracted. So I'm going to use the difference of two squares to factorise. And I'm going to take the square root of each term, and these are going to form the values in a pair of brackets. And then a second pair of brackets as well, and they're going to be multiplied together. So the square root of x squared is x. I'm going to put that at the start of each bracket, and the square root of 4 is 2. I'm going to put that at the end of each bracket, and then one of them will be positive and one of them will be negative. And the reason that this method works is if we were to multiply all this out, the 2x terms, one would be positive 2x and the other one would be negative 2x, and they'll just cancel out. And then the x times the x will give me the x squared, and the 2 times the negative 2 will give me the negative 4. So this is the second example. I'm going to go through exactly the same process. So I'm going to have a pair of brackets and another pair of brackets. And the square root of 4x squared is 2x. And the square root of 9 is 3. And one is positive and one is negative. Now question 3 is a bit more tricky, because I could use the difference of two squares straight away, because I can find the root of 36x squared easily and also the square root of 9 easily. But I can also see that 9 is a common factor, and you should always check for common factors first. So I'm actually going to do some single bracket factorising to get me to that. And now I'm going to use the difference of two squares for what is inside. So 2x plus 1 and 2x subtract 1. Now for question 4, if I was to try and use the difference of two squares initially, then it's going to be a bit awkward, because 50 is not a square number and neither is 18. I could do it, but then I'd end up with surds, and it's not going to be particularly nice. So what I'm going to do instead is I'm going to use a common factor of 2. And now that's given me an expression which is quite nice, because 25 is a square number and so is 9. So that will give me, the square root of that will be 5x, and the square root of that will be 3. So it's 5x plus 3 and 5x subtract 3. Now question 5, this is not a quadratic at all, because we've got an x cubed term. However, if I compare these, I can take x out as a common factor, and the expression inside is a quadratic, and I am able to factorise that using the difference of two squares. Now you're not necessarily expected to be able to factorise cubics on the whole. However, when you have a common factor of the variable, then quite often they will expect you to be able to factorise it, because you can take out the variable x easily using single bracket factorising, and then the resulting quadratic you have methods to deal with.